What happens when something massive slams into a visitor from another star system at tens of kilometers per second? The James Webb Space Telescope just captured exactly that. A catastrophic collision with interstellar comet 3I Atlas that released explosive energy and exposed pristine material that's been frozen for millions of years. But here's what's really shocking. This wasn't supposed to happen. Interstellar space was thought to be mostly empty, yet this comet encountered a debris field that completely reshaped its structure. What does this mean for our understanding of the space between stars? And what did JWST's instruments reveal about this alien visitor's true nature? It began with a flash so sudden and intense that it forced astronomers around the world to stop everything they were doing. In the silent darkness of space, far beyond the moon's orbit, the James Webb Space Telescope captured something extraordinary. A pinpoint of light erupted near 3I Atlas, an interstellar traveler racing through our solar system at unimaginable speeds. At first, scientists thought it might be just another outburst, a common event when sunlight heats a comet's icy surface. But this was different. The light wasn't soft or gradual. It was sharp, explosive, and unlike anything JWST had ever seen from a comet before. Within seconds, the telescope's instruments detected a massive kinetic energy spike, as if something had slammed into the comet with tremendous force. The data was unambiguous. A large object had collided with 3I Atlas. No warning, no prior detection, just a silent impact in the vast emptiness of space, an impact powerful enough to be seen across millions of kilometers. What made it even more shocking was how fast it all happened. One moment, 3I Atlas was gliding silently through the dark. The next, a brilliant flash illuminated the blackness, expanding like a cosmic shockwave. Astronomers scrambled to verify the readings. This wasn't noise. This wasn't a glitch. This was real. In that moment, 3I Atlas was no longer just a mysterious interstellar visitor. It became the stage for a cataclysmic event, the kind that rewrites what we think we know about space. Something out there, unseen, untracked, and fast, had found it. And the energy unleashed was unlike anything expected from a lone comet. But what exactly hit it? Was it a rogue fragment, a drifting asteroid, or something even stranger traveling the same cosmic highway? Whatever it was, it left a signature too powerful to ignore. And it was only the beginning. Long before the collision lit up the void, 3I Atlas was already an object wrapped in mystery. Its discovery in mid-2025 sent ripples through the scientific community. Unlike the comets born in the frigid edges of our solar system, 3I Atlas wasn't from here at all. It came from deep interstellar space, a true cosmic wanderer, carrying secrets older than our sun itself. From the moment it was detected, astronomers noticed something unusual. Its trajectory wasn't elliptical like normal comets. It didn't loop around the sun. Instead, it followed a perfect hyperbolic path, a one-way journey slicing through our solar system at breakneck speed. This was no returning visitor. 3I Atlas was just passing through, and it would never come back. But its path wasn't the only thing that stunned researchers. When JWST locked onto the comet, its instruments revealed an astonishing chemical signature. The ratio of carbon dioxide to water vapor, a key fingerprint in comet science, wasn't the gentle balance seen in local comets. It was 8-to-1 in favor of CO2. That's not just rare, that's alien. If you love exploring the cosmos, subscribe now and like this video for more incredible space discoveries. This extreme ratio meant one thing. 3I Atlas formed in a place very different from our solar system, a region where conditions were colder, darker, and far more volatile. Every molecule trapped inside its icy shell is a time capsule, preserving the chemistry of a distant star system that we may never see. As scientists studied its shape and rotation, more puzzles emerged. Its surface appeared darker than expected, absorbing sunlight rather than reflecting it. Its outgassing patterns were unpredictable, as if something inside it was still waking up after an eternity drifting through the void. This wasn't just another icy rock. 3I Atlas was a message in motion, carrying the story of another world, a fragment of a star system long gone. And now, by pure cosmic chance, it had entered ours. No one could have predicted that soon after, it would become the center of one of the most violent and mysterious space events ever recorded. When the impact came, it was so fast and so violent that not a single telescope on Earth saw the incoming object. No radar alert, no advanced tracking, no warning of any kind. One heartbeat. The interstellar comet 3I Atlas was silently carving its path through the solar system. The next, a high-velocity fragment, no larger than a small asteroid or even a dense clump of cosmic dust, slammed into it at tens of kilometers per second. At those speeds, even something the size of a car can unleash energy comparable to a small nuclear explosion. And this was far more powerful. The collision tore into the comet's surface, releasing a burst of heat, light, and kinetic force that JWST captured with perfect clarity. The moment of impact ripped open part of 3I Atlas's crust, sending plumes of dust and frozen gases spiraling outward. Within seconds, its coma, the glowing halo of material surrounding the nucleus, changed shape dramatically, twisting and expanding like smoke in a sudden storm. It wasn't a gentle release. It was explosive, chaotic, and mesmerizing. Astronomers studying the data saw shock waves rippling through the comet's environment, carving out new structures that hadn't been there before. Jets of material shot out unevenly, as if different layers of the comet's body were being exposed all at once. Some areas released CO2 at an incredible rate, while others spewed ancient dust, untouched for perhaps millions of years. The impact had reshaped the entire geometry of the comet, altering its brightness, its rotation, and possibly its future trajectory. 3I Atlas wasn't just hit, it was transformed. And what made the event even more chilling was the silence. In the vacuum of space, there was no sound, just a bright, expanding plume where two cosmic travelers had collided. Whatever hit it came from nowhere and vanished into the black. But astronomers knew this was more than just a collision. It was a window into the heart of an interstellar object, a chance to glimpse the raw, untouched layers hidden beneath its ancient shell. And what they were seeing defied expectations. For a brief, unforgettable moment, 3I Atlas became one of the brightest objects in its region of the sky. The James Webb Space Telescope recorded the entire sequence in real time. The split-second impact, the violent surge of material, and then the unfolding spectacle of a cosmic wound opening to the universe. The explosion sent ejecta hurtling away at extraordinary speeds, some particles moving faster than 1,000 meters per second. The surrounding coma, once smooth and faint, swelled into a dense, glowing plume, a massive cloud of gas and dust illuminated by sunlight. It was as if the comet had bloomed like a cold, alien flower in the darkness of space. JWST spectrometers picked up something incredible. The impact created new spectral line shifts, signals that had never been observed from 3I Atlas before. These shifts told a story, material that had been buried deep inside the nucleus, untouched for countless millennia, was suddenly being blasted into the open. What emerged was pristine interior ice, rich in volatile compounds, unlike anything typically seen in comets born within our solar system. The brightness of the comet surged temporarily, outshining everything around it. This wasn't just a flash. It was a dramatic chemical and physical transformation unfolding in front of our instruments. Scientists described it as a cosmic autopsy, a chance to peer directly into the anatomy of a visitor from another star system. The plume itself kept expanding, spreading out like an invisible tide. Particles collided, scattered sunlight, and gave astronomers a rare, crystal-clear look at how an interstellar comet reacts under violent stress. It was both stunning and unsettling. And somewhere within that expanding cloud of ancient ice and dust, the answers to some of the biggest questions in planetary science were hidden. What was 3I Atlas made of? What secrets did it carry across light years of empty space? For the first time, humanity had a front-row seat to find out. In the world of astronomy, events like this don't just happen every day. For scientists, the collision wasn't just a shocking spectacle, it was a once-in-a-generation natural experiment. No spacecraft had to land on 3I Atlas. No drilling or sampling missions were needed. The universe itself had cracked open an interstellar time capsule, and James Webb had a front-row seat. By analyzing the way the plume expanded, how the gas and dust dispersed, and how the comet's glow evolved second by second, researchers could map the layers hidden beneath its icy shell. For decades, astronomers have only dreamed of understanding the internal structure of interstellar visitors. Now, that knowledge was unfolding before their eyes. The data began revealing how tightly the comet's nucleus was bound, how its ices were layered, and how its internal pressure built up over millions of years drifting between stars. Even the way the debris moved after the impact told a story about its density, its composition, and its fragile, ancient structure. But it didn't stop there. The event also offered something almost unheard of, a real-time look at the physics of interstellar body dynamics. For the first time, astronomers could observe how a visitor from another star system responds to a sudden, violent collision inside our own. Every second of JWST's data was precious. Infrared readings showed exotic chemical signatures that hinted at complex organic compounds. Spectral variations revealed how different materials vaporized at different rates, layering clues like pages in an alien history book. This was more than science. It was as if the cosmos itself had handed humanity a rare, unplanned experiment, a perfect storm of timing, technology, and mystery. And the deeper scientists looked, the clearer it became. 3I Atlas wasn't just a comet. It was a story carved in ice, written light years away, now being read for the first time. For years, scientists and science fiction alike have painted interstellar space as a quiet, empty void, a vast ocean of nothingness stretching between the stars. But what happened to 3I Atlas shattered that idea. The impact didn't just reveal the comet's secrets. It exposed a hidden truth about the space between stars. If 3I Atlas could collide with an object powerful enough to trigger a visible explosion, that means it must have passed through debris fields, regions of space littered with fragments, dust, and ancient remnants drifting silently for eons. This wasn't supposed to happen out there. Space was supposed to be clean, predictable, safe. The implications are massive. If even a small rock or dense dust clump can unleash such destructive energy at interstellar speeds, then many comets may be damaged, reshaped, or fragmented long before they ever cross into another star system. These objects aren't arriving here pristine. They're scarred travelers, carrying the marks of countless collisions. It also raises serious questions for the future of interstellar travel. If probes, ships, or future human missions ever journey between stars, they won't be moving through an empty vacuum. They'll be flying through a cosmic minefield, where even a pebble-sized impact at tens of kilometers per second could be catastrophic. 3I Atlas became living proof. The silent emptiness we imagine between star systems is, in reality, a vast battlefield of ancient debris, the echoes of star births and planetary destruction scattered across light years. And here's the chilling part. The object that hit it was never detected beforehand. No warning, no signal, no radar blip. It just appeared and struck. If a simple comet can't avoid such a collision, what would that mean for anything we send beyond the safety of our solar system? This single impact wasn't just a cosmic accident. It was a warning written in light, reminding us that the universe is far more unpredictable and far less empty than we've dared to imagine. When the flash erupted from 3I Atlas, most instruments around the world would have missed it. It happened in the cold dark at unimaginable speed, a moment too fast, too subtle, too distant for most telescopes to even register. But not for the James Webb Space Telescope. In that instant, JWST proved why it stands at the frontier of human observation. Unlike ground-based telescopes that struggle with atmospheric interference, JWST's position far beyond Earth's atmosphere gives it an unbroken, crystal-clear view of the cosmos. Its infrared sensors are so sensitive they can detect the faintest flickers of heat and energy. So when the collision occurred, Webb didn't just see a bright flash, it captured the entire impact signature, frame by frame, in exquisite detail. Every fraction of a second mattered. Webb's instruments recorded the spike in brightness, the shockwave rippling through the coma, and the rapid chemical shifts as the comet's hidden layers were ripped open. Normally, comets are studied through their slow, predictable outgassing, like watching ice melt in the sun. But this was the opposite. This was a violent, instantaneous transformation, and JWST followed it without missing a beat. Scientists replayed the data like detectives examining a crime scene in slow motion. They could track exactly how the plume expanded, how the gases interacted with sunlight, and how the nucleus reacted to the force. This level of precision isn't just impressive, it's revolutionary. For the first time, humanity witnessed a cosmic impact in real time from millions of kilometers away, with the clarity needed to break it down second by second. JWST didn't just observe a comet. It caught the universe in the act. This event showed that Webb isn't limited to studying distant galaxies or ancient starlight. It can also capture sudden, explosive events as they unfold, turning moments that would have been lost forever into priceless scientific gold. And if it can record something like this from an interstellar visitor, imagine what else it might catch next. The moment of impact didn't just light up the darkness. It changed the destiny of 3I Atlas. Before the collision, astronomers had already mapped out its path, predicting a smooth swing around the sun before it disappeared forever into interstellar space. But now, everything has shifted. The collision wasn't just a bright flash, it was a destabilizing force that may have rewritten the comet's future. The strike fractured part of the nucleus, cracking through layers that had remained frozen and untouched for untold ages. Those fractures could spread silently over time, weakening the structure from the inside out. And as 3I Atlas hurtles closer toward perihelion, its nearest point to the sun, those cracks could become ticking time bombs. Even a slight rise in solar heat could trigger sudden pressure buildups, leading to massive outbursts or even complete fragmentation. Astronomers are already seeing signs that its behavior is changing. The coma isn't stable anymore. It's pulsing, expanding unevenly, like something is struggling beneath the surface. Its rotation may have shifted, too. Tiny changes in how material vents into space can alter its spin and tilt, sending it into unpredictable tumbling. And with each jet of gas, its trajectory subtly drifts, making future orbital predictions more complex. If the nucleus splits apart, 3I Atlas could transform from a single comet into a swarm of smaller fragments, each following slightly different paths through the solar system. That would create an entirely new observational challenge and a scientific goldmine. Even if it holds together, its journey won't be quiet. As it nears the sun, the heat will tear at the exposed interior, forcing trapped gases to explode outward. This volatile chain reaction could make the comet brighter, wilder, and more dangerous to predict. 3I Atlas entered the solar system as a mysterious, silent traveler. But after this impact, it may leave as something entirely different, a shattered relic of another star system, flaring and breaking apart as it disappears into the void once more. And as scientists track every unpredictable twist of its path, they know one thing for sure: this story isn't over yet. Before you go, don't miss what comes next. Click on the video in the end screen to continue exploring the mysteries of the universe. See more mind-blowing interstellar discoveries. Trust me, you'll want to watch every second. The journey is only getting wilder.